Good afternoon, class. We are looking at pre-calculus practice test for module 4 covering chapters 8 and 9. Chapter 8, application of trigonometry and polar coordinates. And here's part 2. We are going to look at polar coordinates. Again, there's a pledge. I want to remind you before starting the exam, please read the pledge. The concept is very simple. You take the exam on your own. You are assuming that you're taking the exam on campus. All right, so polar coordinates and vectors, plot the points in polar coordinates, -2, 0. So what do we know about that? Let's get started. First, you have the rectangular coordinate system X, Y. You are familiar with that, with the origin O. Now, when it comes to polar, we have the polar axis, or the x-axis, pole or the origin. A pair is represented as x comma y or r comma theta. Okay, so it can be represented as x, the distance from the y-axis, y, the distance from the x-axis. So P has coordinates x comma y, or it has coordinates r theta. R is the distance from the pole, theta is the angle with the x-axis or the polar axis. So to do this, you start with the polar axis. The positive side. You always start with theta. What is theta? 0. 0 degrees is in this direction. If it's positive, you go 1, 2. In other words, let's say it was 2 comma 0. You would go with 2 tick marks on the right. But because it's negative, you go in the opposite direction. -2 comma 0. And the point is this one. Okay, everybody? This one is 2, 0. This one is -2, 0. Now, what about this one? You have the polar axis, pi over 2 or 90 degrees. And how many tick marks? Only one. 1 comma pi over 2. Now, it's important to know if we want to find other polar coordinates for part B, polar coordinates are not unique. R comma theta, we have infinitely many ways of representing that. So R comma theta plus 2k pi, meaning you can go a complete revolution or multiples of that. Or if you want R to be negative, you can add odd multiples of pi. So this is pi plus 2k pi. That means 2k plus 1 times pi, where k is an integer. So let's start with this guy. We are looking at this pair and we want R to be positive. So that means don't change the 1. But theta between -2 pi and 0, all you have to do is subtract 2 pi. So you get 1 comma -3 pi over 2. You want R to be negative and theta between 0 and 2 pi. So if you want to negate the R, just add a pi to that. That gives you negative 1, 3 pi over 2. You want R to remain positive, but theta between 2 pi and 4 pi, just add 2 pi. And you get 1 comma 5 pi over 2. The purpose of that was to tell you that R comma theta is not unique. Okay, everybody? Now plot the points first, then find their coordinates, find the Cartesian or rectangular coordinate system 6, 150. The grid for polar, it should be a bunch of circles, concentric circles. So 1, that means a radius centered at 0, 0, or the pole or the origin, and the radius is 1, and then 2 and 3 and so forth. That's how you locate them. And what you come up with first and foremost, the angle, in this case 150 degrees, you locate that. Okay, 150 degrees. Then you go how many tick marks? 6. That means if each circle represents 1 tick mark, go to the 6th one. Okay, 1, 2, 3, 4, 5, 6. Find the Cartesian or rectangular coordinate system. Well, polar has coordinates r comma theta, rectangular has coordinates x comma y, x is r cosine theta, y is r sine theta. Therefore, we are going to go with x equals r 6 cosine of 150 degrees. And remember, 150 degrees, the reference arc is 30 degrees. So cosine of 30 degrees, which is square root of 3 over 2 in the second quadrant, is negative. 6 cancels out the 2, gives you 3. So negative 3 square root of 3 precisely. We do the same thing with the sine. That means y equals r sine theta. Sine 150, again, like I said, the reference arc is 30 degrees and sine is positive in the second quadrant. So this is the same as sine of 30, which is 1/2. And 6 times that is 3. Therefore, 6 comma 150 is the same as negative 3 square root of 3 comma 3. So going from one format to the next. Find the polar coordinates 2 comma negative 2. 2 units to the right, 2 units down. That's the location. And x squared plus y squared equals r squared. Tan theta is y over x. And as always, you adjust for quadrants. So x squared plus y squared equals r squared. That means 2 squared and negative 2 squared must be added. This is 4, this is 4, this is 8. And so r is square root of 8, which is 4 times 2. 4 becomes 2 and comes out. So 2 square root of 2. What about tan theta is y over x? Clearly, it's in the fourth quadrant. Y is negative. Negative 2 over 2 is negative 1. And theta is negative pi over 4. Therefore, r is 2 square root of 2 and theta is minus pi over 4. So 2 comma negative 2 in rectangular format is the same as 2 square root of 2 minus pi over 4 in polar format. If they specifically ask for a positive angle, all you have to do add 2 pi. Okay. If I add 2 pi, I get 7 pi over 4. Transform the polar equation or cosine theta equals negative 2 to an equation in rectangular coordinate and graph. An easy way is to recognize that x represents r cosine theta, and therefore x must be negative 2. As you know, in rectangular coordinate system, this is a vertical line. So you locate the x-intercept. Okay, this is a grid. that is has the rectangular and polar together, okay? And so you draw a vertical line and you're done. Transform the polar equation r equals 2 cosine theta to an equation in rectangular coordinates and graph. I'm going to remind you that x is r cosine theta, r squared is x squared plus y squared. And when r is 2 cosine theta, the technique, the trick is to multiply both sides by r. So when I multiply both sides by r, what do I get? R squared is 2r cosine theta. If x is r cosine theta, then this must be 2x, and this must be x squared plus y squared. In other words, replace the r squared with x squared plus y squared and r cosine theta with x. And now you recognize, you bring everything to the same side, and you recognize this as a circle by completing the square in the following manner. This one, b is -2, divided by 2 is -1, squared is +1, add 1 to both sides. And the left side, everybody, is just x and b over 2. That means x minus 1 quantity squared. This doesn't change, y squared equals 1. And reminding you that circles have the following equations: x squared plus y squared equals r squared, centered at 0, 0. X minus h quantity squared plus y minus k quantity squared equals r squared, centered at h, comma k. Therefore, this is the circle, centered at 1, 0. Radius, square root of 1, which is 1. And so you locate the center 1, 0. By the way, I'm going with 2 tick marks because it's too small. 2 tick marks represents 1. And here's a circle. Transform the polar equation r cosecant theta equals 8 to an equation in rectangular coordinates and graph. Reminding you of that, that's the grid. And we know the relationship between cosecant and sine. So cosecant is 1 over sine. Therefore, I can replace the cosecant with 1 over sine and say r over sine theta is 8. And the cross product will give me r equals 8 sine theta. Now, class, whether we are dealing with a number times sine or a number times cosine, and on the other side is r, the technique is the same: multiply both sides by r. We did that for the previous example. So when we do that, we get r squared equals 8r sine theta. This can be replaced by r squared equals x squared plus y squared. And then r sine theta is y. So therefore, we get x squared plus y squared equals 8y. We're going to move this next to y squared. B is -8. Divided by 2 is -4. Squared is 16, so add 16 to both sides. This is x squared, this is y minus 4 squared, just whatever b over 2 is, equals 16. And you recognize this as a circle. centered at 0, positive 4. Radius, square root of 16 or 4. So I'm going to erase my work. So I'm going to start with the center at 0, 4. I'm going to go just one tick mark for 1. So 4 tick marks up. 1, 2, 3, 4. The fourth circle. And then draw a circle here. Okay. There's not enough room, but you get the picture. Okay. So the center is located at 0, 4. Identify the graph of the equation and convert to rectangular equation. R equals 4, just square both sides. That means x squared plus y squared equals 60. So R equals 4 is an easier way of representing the same circle which has the center at 0, 0 with the radius 4. So this one, radius 4. Okay. That means the fourth circle. That's the first one, second, third, fourth. Theta equals 3 pi over 4. That's the line. So let's take a tangent of both sides since tan of theta is y over x. Uh, 3 pi over 4, that's a common arctangent is -1. So -1 equals to y over x, which makes y equals minus x, the cross product, everybody. And so when theta is 3 pi over 4, the line is y equals minus x. As you know, y equals x goes through the origin this way, y equals minus x goes this way, right? Identify and graph the equation and convert it to rectangular format. R sine theta equals -3. So that means y equals -3, which is a horizontal line. So you locate 0, -3, assuming this is a rectangular grid, and you have a horizontal. Our cosine theta equals 4. That's x equal 4, which is a vertical line. So you locate 1, 2, 3, 4. That means 4, 0, and then a vertical line. So according to what we have done, we have found the following. Here's the theorem. When R equals a number, we have a circle centered at the pole and radius A. When theta equals something alpha, when theta is fixed, right? Then y equals tan alpha times x. Horizontal line. R sine theta equals A, y equals A. Or cosine theta equals A, x equals A, vertical line. When we have R equals 2A times cosine or sine, positive or negative makes no difference. All of them are circles with radius being equal to A, all of it. In the case of cosine, the center is along the x-axis at A0 or minus A0. In the case of a sine, along the y-axis, 0, A, or 0, minus A. All right, symmetry with respect to WRT, the polar axis or the x-axis. If the polar equation R comma theta can be replaced by R comma negative theta, resulting in an equivalent equation, the graph is symmetric with respect to the polar axis. So think about this. Okay. Point symmetric with respect to the polar axis. So R and R comma negative. Symmetric with respect to the line theta equals pi over 2, the y-axis. If the polar equation R comma theta can be replaced by R comma pi minus theta, the graph is symmetric with respect to the line theta equals pi over 2, the y-axis. Point symmetric with respect to the line theta equals pi over 2. Finally, symmetric with respect to the pole or the origin. If the polar equation R comma theta can be replaced by negative R comma theta or R comma theta plus pi, the graph is symmetric with respect to the pole. You have to check both of them. Sometimes one of them fails, but the other doesn't. So R theta minus R theta. So graph 1 minus cosine theta. First, I want to tell you how we graph a polar graph that is not familiar. Just like we did in rectangular coordinate system, we plot points. What points? We always go with the easy points. By the way, R equals A times 1 plus minus cosine theta, or A times 1 plus minus sine theta, where A is positive, passes through the pole and it has a name, cardioid, because they look like a heart. And so theta or R theta. And I'm going to start with easy points. If I plug in 0 class, as you know, cosine of 0 is 1, 1 minus 1 is 0. If I put pi over 6, 1 minus square root of 3 over 2. If I put pi over 4, 1 minus square root of 2 over 2. If I put pi over 3, I get 1 half. 1 minus 1 half is 1 half. Pi over 2 is 0, so 1. 2 pi over 3 is the same as pi over 3, but it's negative. So just so you can see, for 2 pi over 3, I get 1 minus cosine of 2 pi over 3, which is 1 minus negative 1 half, which is 3 halves. And if I put pi, let me just show you for the pi also. For the pi, I get 1 minus cosine of pi, which is 1 minus negative 1, which is 2. So I'm sure it's very easy to evaluate those. Let me erase my work. And so you write the pairs in front of it, right? And I'm not going to plot all those pairs. I'm going to go with the easy ones, starting with 0, 0. Okay. By the way, R comma theta, in general, when R is 0, it represents a pole. Okay. And I'm going to go with 2 tick marks representing 1. So again, pole is represented with 0 on any angle. Theta can be anything. Okay. All right, then we go with this one, 1 half pi over 3. So you locate pi over 3 and you go 1 because 2 represents 1. So 1 represents 1 half. So you go with 1 circle. 1 pi over 2. Pi over 2 is this one, and you go with 2 circles, 1 and 2, because 2 tick marks represent 1. 3 halves, 2 pi over 3. You locate 2 pi over 3. First, you locate the angle, 2 pi over 3. And then what 3 halves, that means you go 1, 2, 3. Okay? Because each circle is half in essence. 2 pi, pi is this way. 2 means go with 4 circles because again, 2 tick marks, we're going to go 1, 2, 3, 4. And that would be the graph, right? Looking like that. Now, I'm going to look at the concept of a symmetry. If I replace the theta with minus theta, nothing changes because cosine is an even function. So I get the same thing, 1 minus cosine theta. And that means it's symmetric with respect to the polar axis. So symmetry with respect to the polar axis, if in the polar equation r comma theta can be replaced by r comma negative theta, resulting in an equivalent equation, the graph is symmetric with respect to the polar axis. So just for the sake of argument, so you can see right here, if I graph this by symmetry, I should have that. Now you can also evaluate them. I'm going to leave them for you to show. Those are easy. 4 pi over 3. So 1 minus negative 1/2. 3 pi over 2 is 0, 1. 5 pi over 3, it's 1/2 subtract from it, because in the fourth quadrant cosine is positive. 2 pi gives you positive 1, 1 minus that is 0. So you can see this is the top half, this is the bottom half, and that's how you graph it using symmetry. Plot the complex number 1 plus I in the complex plane and write it in polar form. Write data in degrees. I want to remind you that we also deal with complex numbers. This is the real axis. This is the imaginary axis, the one that we had seen before, a plus bi. So z is x plus yi, and it's equal to r cis theta in polar format. R cis theta is the um, shorthand notation for r times cosine theta plus I sine theta, okay? R squared is x squared plus y squared. The modulus or the magnitude z equals r squared of x squared plus y squared. Tan theta is y over x. Very similar to what we have seen. So for this guy, 1 plus I, it is important to understand that the coefficient of I is 1. So you go, this is the real part, 1 along the real part and 1 along the imaginary part. And I'm going to use again 2 tick marks because it's too small. I want to, this is, otherwise you would have 2 plus 2i. I'm using 2 tick marks. So the real line, the imaginary axis, z is x plus iy. This is theta, this is r, and this is z bar, they call it, or z star x minus iy. This is the complex conjugate, complex conjugate. So we plot it, and now we want to write it in polar form. First, we have to find r. R is square root of x squared plus y squared. So 1 squared plus 1 squared, and that gives us 2. So it's square root of 2. Tan of theta is y over x, 1 over 1, or simply 1. Therefore, theta is 45 degrees. So let's call it z. So this angle is 45 degrees. Z, which is 1 plus I, is also equal to r cosine theta plus I sine theta, or cis theta. C for cosine, I, and then S for sine. So r square root of 2, cosine of 45 degrees plus I sine of 45 degrees. All right, question number 10, write the complex number 4 cosine of 7 pi over 4 plus I sine of 7 pi over 4 in rectangular form. And again, this is r cis theta. So just replace the cosine of 7 pi over 4 with, remember, pi over 4 is the reference r. So cosine and sine are both square root of 2 over 2, but 7 pi over 4 puts us in the fourth quadrant positive. Cosine is positive. In the fourth quadrant, sine is negative. So this is square root of 2 over 2. This is minus square root of 2 over 2. So when you multiply by 4, the denominator drops, and we get 2 square root of 2 minus 2 square root of 2i. This is in rectangular form. So that's the plot. We go to the right, 2 times square root of 2, which is about 1.41, 2 times that is about 2.8 to the right, 2.8 down, negative. Find z times w and z over w divided by w and leave the answer in polar format where z is 2 cosine of pi over 8 plus I sine of pi over 8. You can say 2 cis pi over 8. W is 2 cosine of pi over 10 plus I sine of pi over 10. You can say 2 cis pi over 10. So I want to remind you of this very interesting theorem. When z is given in the form of r cis theta, and of course r squared is x squared plus y squared and all of the above. If you have two uh, uh, points in polar format, okay, or two numbers in polar format, and you want to multiply them, z1 times z2 is r1, r2 cis theta 1 plus theta 2, meaning multiply the modulus, the magnitude, and then cis add up their, angles. And if you're dividing, you divide r1 over r2 and then cis theta minus theta 2. So what do we mean by that? We are going to multiply these two. So according to this formula, everybody, we're going to multiply 2 times 2. And then cis theta 1 plus theta 2. This is theta 1. This is theta 2. Two times 2. Then cosine of power 8 plus power 10 plus I sine of power 8 plus power 10. That's it, which is very simple. Now, of course, 2 times 2 is 4. As you can see, the common denominator is 40, right? So if you're going to go with 40, then you have 5 pi here, 4 pi here, 9 pi over 40. So 4 cosine of 9 pi over 40 plus I sine of 9 pi over 40, or a shorthand notation, 4 cis 9 pi over 40. That means the same thing. Now, I want to divide them. So I'm going to put the z at top. I'm going to put the w at the bottom. And clearly, we're going to cross out the 2. Then what about the rest? When you do that, cis theta minus 1, theta 1 minus theta 2. So we write cosine of power 8 minus power 10 and I sine of power 8 minus power 10. And again, the common denominator is 40. Okay. 5 pi minus 4 pi gives you pi 40. And so shorthand notation, cis pi over 40 would be the final answer. We can write it in this fashion. Very simple, everybody. Write in the standard form of a plus bi, square root of 3, cosine of 5 power 18 plus I sine of 5 power 18 to the power of 6. How do we deal with that? All right, so we've discussed the product and the quotient, and now this is known as the Moir's theorem. If z is r cosine theta plus I sine theta, and we want to raise it to the power of n, z to the power of n, raise r to the power of n, and multiply theta by n. So we want to raise this to the power of 6. We are going to raise square root of 3 to the power of 6, and we're going to multiply 5 pi over 18 by 6 for both cases, right? According to this formula. Now, I hope you see that square root of 3 to the power of 6, that means 3 to the power of 3. And this goes away. This changes to 3. Therefore, we write 3 cubed cosine of 5 pi over 3 plus I sine of 5 pi over 3. As you know, 3 cubed is 27. And cosine of 5 pi over 3, everybody, is the same as cosine of pi over 3, and this one is minus, right, sine of pi over 3. Therefore, you write in this fashion. And since we want to, in standard form, we are going to evaluate it. We know cosine of pi over 3 is 1/2, and sine is square root of 3 over 2, and we have a negative, so we write it, and we multiply by 27. This becomes 27 halves minus 27 square root of 3 over 2 I. Standard form, A plus BI, or rectangular form. Given z equals 1 plus I, find z to the power of 10. And to find z to the power of 10, we are going to go with the Morse theorem. To do that, I want to remind everybody, if you go back, we did 1 plus I equals square root of 2 cosine of 45 plus I sine of 45. You can go back to question 9 and find it. All right. So z to the power of 10 follows the Morse theorem. Square root of 2 to the power of 10. And then cosine, you multiplied each one by 10. Square root of 2 to the power of 10 is the same as 2 to the power of 5. 10 times 45 is 450. Now, 2 to the power of 5 is 32, and 450, if you subtract 360, you get to the same angle, which gives you 90 degrees, and cosine is 0, sine is 1. So we get 32I as the final answer.